Hello everyone, today we are going to solve question number 8, which is single element in a sorted array. So I have listed down two approach, that is first approach is OR, using OR, and second approach is binary search approach. Let's read the question first, then we will try to solve it. And question says you are given a sorted array consisting of only integers where every element appears exactly twice except for one element which appears exactly once. Return a single element that appears only once. Your solution must run big O of log n time and big O of one space. So let's try to solve, and let me write the test case. That is example number one. That is 1 1 2 1 1 2 double 3 and double 4 and double 8. Okay, double 4 and double 8. Let me do indexing 0 1 2 3 4 5 6 7 and 8. Okay, so in the question it is mentioned that all the elements except one, all the elements are twice except one element. Like in this case, 2 is the element which appears exactly one times. Otherwise, all elements appear twice in this array. Okay, so we have to find this 2. How we are going to find? The very brute force approach is that, like, go to each element, like going to the first element, see its if its one of neighbor is equal to this element, then this is not a element which we are looking for. If it is not, then go to its next element. Like for this, if you see for the first index, its previous element is equal to the current element, then this is also not the element which we are looking for. Now go to its next element and see its neighbors, like checking its previous, which is not equal to, and checking its next, which is again not equal to. So this is going to be my answer. uh, this is going to be my answer, so I'll return this as my answer. So this is my answer. Okay, let's say if it is not my answer, considering, so let me create those things. Then we will go to its next element, and for this you will check for this its previous and its next. Since its next is equal to the current element, then this is not again equal, this is not our valid answer. So we will go to its next element and we'll go to every element and check. Okay, so this is the brute force approach, and the time complexity of this will be big O of n, because we are going to each and every element, and then we will check its neighbor. If one of the neighbor is equal to, that means this is not the answer, so we will move to its next element. So this is a brute force approach. Now we have to solve n big O of n as question demands. How we are going to solve? Because it is sorted, we have to use okay, there is one more approach. Like let me explain this. Whatever I explain, that is also big O of n. There is one more approach which is popular. Let me explain that one. Like if you know the XOR property, like XOR property, what XOR property says, if you have the same, if you do same XOR same, like if you have an integer x, let's say whatever x is, like integer it should be, and if you do XOR of XOR with same element, then it will gives us as a 0. This property is uh, enough for the solving this problem. Like, and one more property you have to remember, like okay, so if you do XOR with, if you do 0 XOR x, then it will gives s x as it is element. Okay, these two properties are enough to solve this problem. Let's see how. Let me erase this thing. Okay, now we will go to each element and do XOR. Initially my XOR current, let's say current is 0. Now I'll do current XOR 0. So current will be current. What is current? Current is 0. Let me erase this. Current is 0, and we will do XOR with the first element, it will be 1. So it will 0 XOR 1. Now we will go to its next element. Now again I'm XOR with current element. So current element is 0 XOR 1, and I'm again do XOR with 1. So the property says that if two elements have the same XOR, then if two elements are same and we are doing XOR of these two elements, then it will become 0. So 0 XOR, this will become 0, and 0 XOR 0, this is again 0. Go to its next element, that is 2. We will do XOR. then go to its next element. This is the XOR. Now we will do XOR of bit 3. Then go to its next element. This is the XOR of the current. Then we will do XOR. Now if we do same integer XOR, then it will become 0. So it looks like 0 XOR 2 XOR 0. If you do XOR of 0 XOR 0, you will get 0. So XOR 2. Now go to its next element. It will be 4. Go to its next element. It will be 4. So 4 is 4 is 0, and 0 XOR 0 is again 0. So 0 2. Now go to its 8, and again 8, 2 twice, 8 XOR 8. So it will become 0, and 0 XOR 0 0, and 0 XOR 2 will be 2. So this is our answer. So basically it will cancel out if you have a number which is present twice, and if you take XOR with the same, then it will cancel out. So it will make it 0. All the elements which present twice make it 0. If one element is present, then all the XOR with 0 to element x, let's say, it will give us x. So this is the property of XOR. It will cancel out each other if the element is present twice. Like if you do XOR like 2 2 2 2 4 times, then it will cancel out 2 2, then it will become 0, it will become 0. And if you do XOR 0 XOR 0, then it will be 0. So let me write a code, pseudocode for it. Let's say for int I equal to 0 to I is less than n, I plus plus, maintain a variable called current. Initially current has 0. Now current equal to current XOR a of I. Okay. After that loop ends, then simply return current. Okay, so this is the solution, and this is also going to take big O of n, because we are going to each and every element. So that's it. This is the brute force approach. Now we will discuss the binary search solution. Because it is sorted, we can apply binary search. Let's try binary search. Okay, so let's take an array. Again, same array. 1 1 2 3 3, 1 1 2 3 3 4 and 8. Okay, so let's do indexing 0 1 2 3 4 5 6 7 and 8. So we have to return an element which is present exactly one time. So let's check the first element, because if the element present in the first at the first, एक second, this one. Okay, so I will check separately for the first element of the element and the last element of the element of the array. Like I'll check for one is the single element. I am going to check its neighbor. Like there is no neighbor to check, so I will not check here. So I'll check here. If it is equal to 1, that means this is not the element which we are looking. Now we will check for the last element. I'll go to its neighbors. There is no mean to check here. Now I'll compare with this. If this is not equal, if it is equal, that means this is not the solution. This is not the element which we are looking for. Like if it is not equal, like if there is 7 present, that means this is the element which we are looking for. Like this is the element present at once. So we will check it separately. Like these two cases are handled separately. Let me write it here. If my a of 0 is not equal to a of 1, that means this a0 is my single element. So return a0, return a0. Else if my a of n minus 1 is not equal to a of n minus 2, that means my last element is single element. So I'll return that. So these two cases I'm going to handle separately. Now remaining cases are, if this is not true, then my low pointer is pointing to the first element and the first indexed element, and the high pointer is pointing to the index 7. Because we are already checked for the first and the last element separately, we don't have to check again in the search space. So we will start low from index 1 and the high at the index 7. Now we will calculate mid as the standard binary search. Whenever we use binary search, we always calculate mid. and there is mid will be, how we will calculate mid, equal to low plus high divided by 2. Here low is 1 and high is 7, divided by 2, and 8 divided by 2, it will be 4. So 4 is going to be our mid. So let me mark it 4 where it is. Here it is. This is the 4 and this is going to be mid. Okay, so now we have mid. We will compare. Firstly, we will check, is this a single element? How we are going to check? We will check with condition. We will apply a condition, like if my array of mid is not equal to array of its next element, or mid plus 1, and array of mid is not equal to array of mid minus 1, its previous element. If this condition is satisfied, I am going to return array of mid as a single element. So this is the very checking condition, like whenever we we calculate a mid, then we will check for its condition, like if it is a single element or not, checking its comparing its bit neighbor. If one of those neighbor is equal to the mid, then this is not the single element. Now let me erase these things. I hope this will be clear now. Let me, okay, so now this is not a single element, not a single element. Then what we will do, like we always do, and likewise we always do in a binary search, we have to select in which half we will go, left half or right half. How we are going to decide this? We will apply two conditions for a left half and the right half. Now in this case, like if you can see, like if we compare with this, its next element, or previous element or its next element, you can see its previous element is equal to the mid value. So we will count number of elements present in the left side, like what are the are the elements are present in the left side. This is 1 2 3 4, 4 elements present in the left side. Now think, if 4 elements present, if it is equal, like say 1 1 2 3 and 3, this is the your mid. Yes, if there is 4 element present, this is your mid and this is equal, so these are cancel out each other, and there is now left with 3 elements are there. That means there is one element present which is again going to be single, because this makes pair itself, 1 and 1 going to cancel, there is one element remain a single. So we will move to here. How we are deciding? Like if there is an even 1 2 3 4 even number of elements present and equal side, like I am checking in equal side, like if the previous element is equal to 3, that means we will check a number of elements. If there is number of elements is even, then we are going to say there is an element, so we have to search in the left part. Okay, this much of clear. Let's take one more example to better understanding, and we are going to take a of its second example, 3377. It says 3377 and 10 11 and 11. I think I am correct. Yes. Do indexing 0 1 2 3 4 5 6. Low is pointing to here, high is pointing to here. Okay, now if we calculate mid, so mid will be 5 plus 1 6, 6 divided by 3, this is going to be mid. Let me mark it. This is going to be mid. Now firstly I'm going to check its neighbor. The both neighbor should be unequal to the mid element, but here is the element is equal to previous element, so this is not the single element. So now we have to move to left half or the right half. So how we are going to do, like its previous element is equal, this is equal, this 2 is equal. Now we will check its left number of elements. How many number of elements are there? It's 3, so its odd number are there. So if there is odd number equal side, let's say 3 3 and 7 7. This is your mid. Okay, now if you do a pair, then the remaining elements is 2, and this is also going to be pair. It will cancel it out other, so it will become, there is no single element, so we have to move right half. So what we have decided over here is that whenever we found an equal element, like if you found an equal side element, then you have to calculate its number of uh, number of elements present in the equal side. Whatever number of elements present in the equal side, according to that you will go to its left or you will go to its right. Okay, so let's write it code and you will understand better. So let's go to code part. Okay, so let me create a variable n which will store the num size. Now one will low is firstly we will check the first, if my num n equal to 1, if there is one element, then I'm going to return that element. It will be nums of 0. If it is not, that means uh, length of array is greater than or equal to 2. Now there is at least 2 element. Now I'll compare nums of 0. If this is not equal to nums of 1, then I'm going to return nums of 0. Now we will check for last element. Nums of n minus 1 is not equal to nums of n minus 2. If this is the case, then I'm going to return nums of n minus 1. Okay, now my low is pointing to the 1 and my high is pointing to n minus 2. While low is less than or equal to high, calculate mid will be low plus high divided by 2. Now I'll check if my nums of mid is not equal to nums of mid minus 1, its previous element, and also nums of mid is not equal to nums of mid plus 1. If this is the case, that means this is a single element. I'm going to return nums of mid. After that, this, if this condition is fails, then I'll go to next condition. If my nums of mid equal to if my nums of mid equal to nums of mid minus 1, if my previous element is equal to the mid value, then if my okay, so here it is 4 2 1 or 0, it's remaining element. If remaining element, so it will be mid. If mid is going, if it is odd, if it is odd if it is odd, let's say if it is odd, then I'll move to right half, which is mid plus 1. Else I'll move to left half. Else this is not the case, then we have only one case left, that is if my nums of mid equal to nums of mid plus 1. And then we will calculate length first. How we will calculate length? Let's say this is the my mid, and what is the number of elements is there? 6. That is 7 minus 3. 7 minus 3 will be 4. So it will be n minus mid minus 7 minus 4 will be 1. Okay, so there is 3 element present. So I'll do this. Okay, my if length is mod 2, that means if it is odd, then I'm going to if it is odd, what we will do, like if it is odd, then I'll go to its right part, sorry, left part. It will be mid minus 1. Else I'll go to its right part, so it will be mid plus 1. I think this would be correct, like n minus 7 minus mid 7 minus 3 will be 4. 4 minus 1 is 3. If 3 is there, that means this is the equal, so I have to search in the left half. So I'll go to know, okay, this thing is correct. After that, if there is no single element, that is not possible, because in the question it is mentioned there is exactly one element which is single. So in this case we will just return anything. Let's try to run and see. It is accepted. Let me submit this, and this is correct. So that's it. Thank you for watching.